Let's jump back to our first example. We know as time spent playing violent video games increases, aggression tends to increase as well. Does that mean, as the newscaster claimed earlier, that playing violent video games causes aggression? No, correlation is not causation. You may have heard that phrase before, but what does it mean? Put simply, it means that X may be causing Y, but there are other plausible explanations governing X and Y that correlational data cannot rule out. Going back to our example, this means it's possible playing violent video games causes aggression, but perhaps there's something else going on. But what? To help us answer this, let's look at a new relationship, that between ice cream sales and drowning. As we can see, there's a positive correlation between the two. As ice cream sales increase, drownings tend to increase as well. Well, that settles it. If you want to reduce drownings, ban the sale of ice cream. That conclusion is, of course, ridiculous. No one would actually endorse such a ludicrous policy. However, such a conclusion is no different than saying banning violent video games will decrease violence. Both of these conclusions make the faulty assumption that because there's a correlation between two variables, one must be causing the other. Okay, so we know ice cream sales aren't causing drownings. What really is going on here? The answer is that there is a third variable, Z, sometimes called a lurking variable, that's causing both X and Y. In this case, Z is the outdoor temperature. When it gets warmer outside, more people tend to go swimming, and unfortunately, this results in an increase in drownings. Similarly, when it's warmer outside, ice cream sales increase. So, the increase in temperature, Z, is explaining both drownings, Y, and ice cream sales, X. There is no direct relationship between X and Y, and suggesting as much is misleading. Back again to our primary example, if video games aren't causing aggression, then what's really going on? The question you should ask yourself is, what possible third variable, Z, could be causing both X and Y? In this case, one likely culprit is personality type. Perhaps innately aggressive people, who are prone to committing aggressive acts, are inherently drawn to violent video games. This suggests that limiting a child's access to violent video games would have no effect on their aggression, just as a citywide ban on ice cream sales would have no effect on the incidence of drownings. So which is it? Are violent video games causing aggression, or are individuals with aggressive personalities prone both to committing acts of aggression and playing violent video games? Unfortunately, with the data we gathered thus far in our hypothetical study, we simply cannot answer this question. Either one of these explanations is possible. If we want to figure out what's really going on, we'll need to devise an experiment, the only scientific methodology that allows us to draw causal conclusions. To begin, we'll need to start with a hypothesis, or a proposed explanation for how something works. Let's generate our hypothesis from our correlational study. We know there's a correlation between playing violent video games and aggression, so we'll hypothesize that the nature of this relationship is causal. Playing violent video games causes aggression. Now that we have our hypothesis, it's time to test it. To do so, we will recruit 20 new children. If you'll recall, in our initial correlational study, we, the researchers, didn't manipulate any variable. The children were free to play as little or as much of the violent video games as they pleased. In our experiment, that will no longer be the case, as we will purposefully manipulate how much exposure each of our participants has to violent video games. This variable we're manipulating is called the independent variable and is the hallmark of the experimental methodology. 10 of our participants will be randomly assigned to the control group, or the group where the hypothesized causal variable is absent. Over a 1-week period, we'll make these children play 30 minutes of non-violent video games each day. The remaining 10 will be assigned to the treatment group, the group where the hypothesized causal variable is present. These children will play 30 minutes of violent video games each day. In both groups, children will be prohibited from any other video game playing for the duration of the week-long study. Notice the similarities between the two groups. Both are playing video games. both are playing for the same amount of time each day. The only thing that differs between the groups is the presence or absence of violent content in those games, our independent variable. Throughout this 1-week period, just like in our correlational study, we'll be monitoring children's behavior, recording the number of aggressive acts committed. This is our dependent or outcome variable. According to our hypothesis, violent video games cause aggression. Accordingly, we should predict that those participants who were randomly assigned to the treatment condition should, on average, commit more violent acts than those in the control condition. Let's fast forward through the data collection and see what we find. Again, I'll draw my x and y axes. My y-axis is unchanged from before. It's still aggressive acts committed from 0 to 20. My x-axis, conversely, has changed. Before, it was on a scale from 1 to 10 because participants were free to play as much of the video games as they please. Now, we only have 2 possibilities. The participants were playing either non-violent video games, the control condition, or violent video games, the treatment condition. We'll plot the average number of aggressive acts committed for each group separately. Oh no! Our hypothesis was disproven. The participants in the treatment condition committed no more acts of aggression than our control condition. Accordingly, we must conclude that there is no causal link between violent video game playing and aggression, that there must be some third lurking variable explaining the correlation we found previously. Importantly, just because there's no causal link between video games and aggression doesn't mean we should just ignore the correlation we found earlier. As discussed in the previous video, correlations are indispensable for their ability to help us predict outcomes. For example, a student's score on the SAT correlates well with his or her GPA in college. Of course, there is no causal link here. SAT performance isn't causing higher GPAs. Nevertheless, admissions officers at colleges and universities are interested in SAT scores because it helps them predict which applicants would be more likely to succeed at their institution. Similarly, if your child seemed obsessively preoccupied with violent video games or other types of media, that may give you an indication of his propensity to commit acts of aggression. Correlational studies are prominent throughout a variety of scientific disciplines and can be very informative. However, just because 2 variables are found to correlate with one another does not mean that one is causing the other. The only way to make that determination is with an experiment. Knowing correlation is not causation will help you not only in this course, but in evaluating sources of information more generally. You'll be shocked at how often the media ignore this point.